This is going to be the second installment of our graphing transformations, multiple transformations in one. And so this one, we usually start with our parent function. So our parent function on this one is y equals the square root of x. And then, as I said in the first video, if you happen to watch that one, we'll make a table for our x and y values. And what I said was we typically will pick -2, -1, 0, 1, and 2 for our x values. But in this case, those wouldn't be very smart ones to choose, because put -2 in, you end up getting an imaginary number. Same thing with -1, so that's not going to work. We're not going to be able to graph those. And then if we choose 2, that's also not going to be the best choice. So let's choose some smarter numbers. Set up our table again. And so what I'm going to do is I'm going to start with 0. Square root of 0 is 0. And then I'm going to go to 1. Square root of 1 is 1. And then I'm not going to go to 2. I'm going to pick the next number that has a nice square root. So let's go to 4. Square root of 4 is 2. Now, let's not be discriminatory. All the square roots are nice, but I'm looking for whole number answers. And then we'll do square root of 9, and that's 3. So we've got 0, 0, 1, 1, 4, 2, 9, 3. So we're going to connect these dots, and this is going to be our parent function, which is the square root of x. So now what we're going to do is we're going to, as we did before, we could make a table for this offspring function, or we could be wise about it and choose some, use our transformations that we know. I think what we'll do on this one is we'll make a table again, and then after that we're going to, on the third video, we'll try doing it without a table. So once again, let's be smart about our x values. What we want to do to start is we want to find something that's going to make the inside or under the square root equal to 0. So I'm going to start with x equaling -2. If we put -2 in there, got -2 plus 2 is 0, -0 is 0, square root of that 0, times 2 is 0, plus 6 is 6. And so we should be able to tell from this equation that this is going to be left 2 up 6, left 2 up 6, 1, 2, 3, 4, 5, 6, right there. So that's going to be where it starts. That's going to be equivalent to the origin on the pink one. And then we're going to have to figure out where does it go from here. And so let's pick y's x values. And so if I put -1 in here, -1 plus 2 is 1, but then this makes it negative, and then we're dealing with some imaginary numbers. So I'm going to go to -3, because -3 plus 2 is -1, and -1 is +1. Square root of that is 1, times 2 is 2, plus 6 is 8. All right, so then what I want is I want to get the inside of this to equal 4. And so what I want is in the parentheses to give me -4. So that's going to go -6. -6 plus 2 is -4. -4 is 4. Square root of that is 2. 2 times 2 is 4, plus 6 is 10. And so if we keep going, this is going to be off the graph. So we'll just graph these three and see what it looks like. -3 up 8, right there. And -6 up 10, so right there. So this one, I don't like that line. Let's start fresh. This one's going to look something like that. All right, and so once again, we could do this without the table. We don't really need that table. If you notice, to go from the first point to the second point on the pink graph, it's up 1 over 1. Now, it's not really a slope of 1 because it's a curve, but instead of going up 1 over 1, this 2 out in front here, that is a vertical stretch. That's pulling it up vertically. So vertical stretch by a factor of 2. by a factor of 2. So what's happening is instead of going up 1 over 1 like we do on that pink graph, we're going to go up 2 over 1. It's pulling the graph vertically like so. And so every time we go over 1 instead of going up 1, we're going doubling that, so we're going up 2. So for the second point, if we start out at the origin, we went over 4 up 2. So instead of going over 4 up 2 from the beginning point, we're going to go over 4 up 4. It's stretching out that y value by a factor of 2. So when we say vertical stretch, it's doubling how far up it's going to that next point. And so if we use that same logic, it's going to be off the graph. We can kind of get an idea of where it's going to be. And it's going to be, instead of going over 9 up 3, we're going to go over 9, which would get us like somewhere over here, and then up 6. So that would get us our next point somewhere, you know, it'd be up off the graph, but it'd be somewhere over there. So we could use the vertical stretch to help us find those next points. So instead of making a table, you could do the left and right shift, do the reflection, because it reflected across the y-axis, so it's pointing to the left instead of to the right, and then it stretched it twice as much up. All right, so there's example number 2. Stay tuned for example number 3. If you'd like to watch that one, click on that one now.